So it's great to speak a little bit about these requirements, why they exist, how to comply, and what are design strategies to maximize value. So just a little bit about Dunsky. Dunsky advises utilities, different levels of governments, and the private and nonprofit sector on how to achieve the energy transition. What I want to chat about today is, firstly, I'll just give a really quick overview of trends in the electric vehicle space and why these requirements exist and are important. I'll speak a little bit about EV charging and what I mean by EV ready, and then a bit about EV energy management systems, which are a really important set of technologies to help enable large percentages of parking spaces, e.g. 100% of parking to ultimately feature EV charging at them, and a bit about the EV charging service provider sector. And then I'll touch on these new construction requirements and how they're structured. Say a little bit about some different design considerations that developers and electrical engineers can think about in order to try to add the most value, both from their perspective as well as from the occupants. And then depending on time, I'm not sure if we'll be able to get to this, but it might be neat to chat a bit about what we can do in existing multifamily buildings, because new construction is of course important, but in order to hit these goals of EV uptake in Toronto, it's going to be absolutely critical that we also address the existing building sector. So EVs are a greater and greater proportion of sales, and over the course of the next decade are, I think, going to be, and it's not just myself, the far and away predominant form of drivetrain that we see in new vehicle sales. And that's because the cost of batteries that are in those vehicles is declining. So lithium-ion batteries have gone from about $1,000 a kilowatt hour in 2010 down to the best industry average estimate is $130 in 2021. And this is due to economies of scale, technology advancements, learning by doing, and basically every time the battery manufacturing capacity in the world has doubled, we've seen a cost decline of about 18 to 22%. And that trend's been consistent for the last 40 years. And I think we can count on that continuing. What that means is that the cost of pure battery electric vehicles with long range, while it's at a premium above internal combustion engine vehicles now, is going to decline to the same and subsequently lower price than internal combustion vehicles. So it'll be cheaper to produce and presumably to sell these vehicles by about the middle of the next decade. This graph is from the International Council on Clean Transportation. They're a major NGO working in the space. A lot of other analysts tell basically the same story. We've got these three vehicle types: pure battery electric vehicles with 250 miles of range, a little bit shorter range at 200 miles and 150 miles. And you see the costs to produce them plus a profit margin declining to the same and then subsequently lower price. In this case for an SUV, this will happen a little bit quicker for passenger cars, but about the middle of this coming decade, we're going to be at that price parity level. So after that point, you've got vehicles that are the same and subsequently lower price to purchase. They're about a fifth of the price to fuel, even less today with our high gasoline prices, half the maintenance costs, zero emissions. It's hard to understand why people are going to want to keep purchasing internal combustion vehicles when there's these types of options, provided they've got a convenient place to charge. So moving forward, access to charging is the most important factor determining whether or not households are going to choose an EV for their next vehicle. And as Sophie mentioned, there's also policy driving this, most notably the federal zero emissions vehicles requirements, 100% by 2035 for all new vehicle sales. So I'll quickly do an overview of EV charging. Broadly, there's three levels of charging. AC level 1 is 120 volt, so that's like a household outlet. Some households make do with this. That can provide maybe 8 or 9 kilometers per hour of charging for a Tesla Model 3, probably more like 2 or 3 kilometers for an F-150 Lightning. So some households can get by with that, but especially as we get into these larger vehicle types, really there's going to be the predominant demand for level 2 charging, both at home, at work, and then some out and about on the go types of locations. We'll all use level 2. So level 2 is 208 volt or 240 volt. That's like a dryer plug voltage, anywhere between 12 and 80 amps. The most common amperage would be maybe 32 amps or 40 amps. delivered to the vehicle. So that provides about 40 or 50 kilometers per hour of charging worth of electricity to the vehicle, and there's a lot better quality of service. And then there's very fast charging, DC fast charging, and you typically won't have that implemented in a residential context or in a lot of commercial contexts. Although for places where your vehicles can be parked for relatively short periods of time, maybe an hour or less, that's where you want to have that DC fast charging infrastructure. Access to home charging is the most important factor determining whether or not people are going to adopt EVs. So right now in North America, about 80% of all charging that takes place is at home. Maybe about 15% is at work. So you're an employee, you come to work, charge up. And then a relatively small but important part is when people are out and about on the go, either on long trips connecting city to city, or just if you're going to the grocery store, you want to top up, or you don't have access to charging in other contexts, you also charge there. But the base of the pyramid, where people really want to charge, is overnight, where they park their car regularly every evening. It's pretty simple if you've got on-site parking in most single-family homes to have access to level 2 charging. It's a low-cost electrical renovation. Conversely, in multifamily buildings where most households live in a city like Toronto, it's really costly and complicated to implement that EV charging. So if we can get to it at the end, there are some creative ways to do this that can really reduce costs substantially. But in the way this has been typically done, you're looking at a cost of maybe, if you're lucky, $5,000, but often, I'd say in BC, the average has been about $8,000 or $9,000 per parking space. It can easily get up to $15,000 or $20,000 to add one charging station. So it's not a scalable model. It's a real barrier and an added cost to have that access to charging implemented. In condos, you've got the added complication that it's really difficult to make these electrical renovations to common property. And you can quickly exceed the capacity that's available in those buildings if you're not designing carefully. All of which means, again, getting charging access in multifamily is a real challenge, and it's important that in new construction, we basically staunch the bleeding as fast as possible, make sure every building built from now on is going to provide those residents, if there is on-site parking, and it's absolutely wonderful. Like, Michael, kudos to you. It's fantastic to be reducing the amount of on-site parking that we're building and sort of trying to encourage people to have alternatives to the automobile. But if we are providing parking, enabling folks to own a vehicle, we at least need to give them the opportunity to easily install a charging station and choose an EV as their next vehicle. So that's why we want to make parking EV ready. Now, what does EV ready mean? Basically, it's that you've got an electrical outlet that's adjacent to the parking space. So this simple schematic, it looks kind of like a single family home, but you can imagine this being the same sort of future proofing in a multifamily building, where every parking space would have this adjacent outlet beside the parking space. And then as households adopt EVs, they'll install an EV charging station at that outlet. And in order to put that in, you need all the electrical infrastructure upstream of it to comply with the Canadian Electrical Code, make sure it's safe. That needs to be sized appropriately and wired so that you've got that energized outlet there and available. And outlet, we often would think of this colloquially as being a receptacle. It can be. There's certain designs where that's okay, but usually you're talking about a junction box where in the future you're going to hardwire in a charging station. So I'll say a little bit about these EV energy management systems, which I noted are a really important set of technologies to enable large amounts of EV-ready parking and subsequently EV charging. So basically, EV energy management refers to charging stations that have a bit of intelligence, and they can communicate over a network. So in this example here, we've got one branch circuit. Let's say that's a 40 amp to 8 volt branch circuit, and it's serving, let's say, 4 parking spaces. So if just one of these vehicles is plugged in and charging, it can get the full capacity of that circuit and charge at a relatively quick rate, let's say 50 kilometers worth of charge an hour. If multiple vehicles are there and plugged in, then the charging stations communicate across that network. They can throttle down their consumption so that you're still just using that 40 amps and you're not exceeding the capacity of that circuit and tripping the breaker. So you are slowing down the rate of charging when that's occurring, when multiple vehicles are charging simultaneously. But for a lot of contexts, notably residential, that's perfectly fine. You've got a 12-hour period overnight when people are there. It's really unlikely everyone's going to come home, 4 neighbors in a row needing 300 kilometers worth of charge, each of them. There's in an overnight period, maybe about 500 kilometers worth of charge that can be delivered. So you average it out, every vehicle is going to get a sufficient amount of charge the vast majority of the time when you're using these sorts of systems. And the advantage is by doing that load sharing, you're significantly reducing the electrical capacity that you need to implement in these buildings. That reduces the amount of copper, the size of the utility service, how big your equipment, your distribution switchgear and your transformers are, and that substantially reduces costs. It can also provide a lot of value to the users. So you won't have nearly as high demand charges by having such peaky use because you are sharing with your neighbors, so your electricity costs will be lower. You can participate in utility demand response sort of events. So the utility can say, hey, we're at a peak event right now. Can you hold off charging for a couple of hours, and they can compensate folks. So I think moving into the future, the ability to provide that type of managed charging is going to be absolutely critical to enabling a high renewables, zero carbon, fully electrified future. There's a variety of different sorts of electrical configurations that EV energy management systems enable. So in this example I just showed previously, this is one 4 vehicles sharing a branch circuit. So it's this kind of simple circuit sharing arrangement where you basically have one branch circuit coming off your panel and all the sharing is occurring on that electrical branch circuit. And you're just doing your control at the branch circuit level. Now you can also do panel sharing, where all the sharing is occurring at the panel level. In single-family homes or in townhomes, you sometimes do this sort of feeder sharing arrangement, where if this is your meter that's on your single-family home, it has a feed that's then coming into your residential panel, and there's some monitoring on that feed that says, okay, there's capacity on that feed, like there is the vast majority of the time. We can allocate charge to your EV charger. But on that one day a year, it's minus 30 out, your heat pump's working overtime, you're cooking Christmas dinner for everyone, so your oven's on, you've got a load of clothes in the dryer, then you're getting close to that capacity and it can throttle down or just switch off the EV charger. And that way you don't need to upgrade to a larger panel and service size. So that can be quite a valuable sort of suite of technologies in those sorts of applications. And then finally, a similar sort of idea, but in larger buildings, is what we call service monitoring. So here, if this was the schematicized electrical system for a large multifamily building, this is your service into that building, and it goes off your transformer and into your main switchboard. You've got monitoring right there, and I'd say, yep, there's capacity, we're communicating to the EV charging, you're okay, you don't need to do anything. But if it's approaching capacity, it's getting, let's say, within 80% of the capacity of that service into the building, then it can communicate to the EV charging to start to throttle down. What that allows us to do, either in existing or new buildings, is not need to upgrade utility services. So if you've got new construction, you're planning on a certain electric utility size, you could design it so that it's easy to implement this sort of control. And because of the additional loads that EV charging entails, you don't necessarily need to upgrade your utility service. This is still a relatively rare and nascent form of charging infrastructure and of EV energy management, but there are systems that have been implemented that use it. In my previous role with an electrical engineering firm, we've done buildings that use that type of control and avoid an electrical service upgrade. So sometimes an electrical service upgrade won't really have significant cost impacts for new development. It's okay, but for those that could be impacted by higher costs, this is kind of an important arrow to have in the quiver. Relatively rare, but a useful design strategy. So just to illustrate the value of these sorts of EV energy management systems, If you were to do this without any management and just have a 40 amp circuit to each parking space in this mid-rise building, this is your cost per parking space. By the way, this is from this costing study that we did for Ontario municipalities. If you had a 40 amp circuit to each parking space in that building, you're looking at about $5,500 per parking space to make all those spaces EV ready. But we looked at a variety of different scenarios that are using EV energy management, various load sharing configurations. And the high level takeaway is when you're doing that design for load sharing, lo and behold, a lot lower costs. The lowest cost option here was about $1,500 per parking space. The study was done at sort of the height of construction cost inflation, and a lot of the other costing studies we've done finding even more modest cost impacts. So you can broadly see the value of considering these sorts of strategies. Now, how much sharing you can get away with is a product of a number of factors, you know, when people come home, when they leave, how cold it can get. When it's minus 30 out, your car heaters are on, your vehicle's less efficient, you need more power on average. But the most important factor is how far people drive. So as part of our work, we did this study that took data on how far people drive in the GTHA, and then did a variety of statistical analysis and said, okay, given how far folks drive, how much load sharing can you get away with while still ensuring that everyone's going to receive enough power that they need to get where they need to go the next day, 99.9% of the time. And based on this analysis, we found that here in, I guess, most parts of Toronto, where you've got 45 kilometers or less a day, so that's basically York on in, Guelph on in, you can get away with 4 share on 40 amp circuits. So previously the Toronto Green Standard let you do up to 3 share. We said, actually, that might have been a bit conservative. We can do a little bit more load sharing and still provide a really good quality of charging service for people. So that's a bit about EV energy management and how much sharing is appropriate in the region. I also just wanted to touch on the EV charging service provider business. When you design for EV energy management, you need to ensure your charging stations will actually be able to communicate with one another. So you need to set the building up for success. Typically, they'll have a contract or a relationship with an EV charging service provider who's going to give them charging stations that are capable of doing energy management and communicating with one another. But those network charging stations can also serve a lot of other functions. They can provide access control, so you can only activate the charger and start using electricity if you're registered and you've got, you know, your right app or key fob certification. They do utility energy cost billing, so they'll be the conduit that charges the driver in some way for the cost of the power that they're using. The strata or the rental building owner will be paying the utility bill, but then the charging service provider collects that money every month or annually from those drivers, and they reconcile the costs to the condo or the rental building owner. So those condos are made whole and they're not subsidizing people's cost of power. So they can facilitate that kind of service. And also in the future, increasingly do things like utility demand response. There's a federal policy, the Clean Fuel Standard, that's going to set up opportunities for anyone who's providing EV charging to generate revenue. So condos can actually make money by selling carbon credits from the revenue that's generated through the value of reducing emissions from their transportation. So there's a whole range of types of services that this sector can provide the occupants of these buildings. So this is a map with, I think, the Northwest Territories not visible, of jurisdictions in Canada that have adopted these EV ready requirements. So this has been pretty popular in BC. It's the vast majority of the new development in the province. It's now covered by these. So it's been each local government sort of one by one adopting them. I was actually a staff person at the city of Richmond when we did the first back in 2017. I think it was definitely the first in North America. It's wonderful that Toronto's adopted this same requirement, 100% EV-ready new residential as well as 25% non-residential parking. And we've been working with Calgary, Edmonton, Halifax, other jurisdictions north of the border, and then a variety south of the border too that are seeking to replicate this same model. So Lisa already had this language up there, basically saying all residential parking spaces need to have an adjacent energized outlet that's able to provide level 2 charging, 25% of non-residential. And then, as you noted, in the Toronto Green Standard, that's where those performance requirements are referenced. So these say this is the maximum amount of load sharing that you're allowed to do. If you want to go overboard and provide sort of a lightning bolt to each parking space, dedicated circuits, you're allowed to do that. It is the rare development in my experience that does that, but some have wanted to do that to sell sort of a more luxury sort of asset. Most will use this sort of minimum to try to keep costs down while still providing sort of a great charging experience for the residents of their building. So I'll just say a little bit about some general strategies to maximize value in new developments, with the caveat that firstly, I'm not an electrical engineer. I just like to chat with them and learn a little bit from them. And really it is, ultimately the responsibility of electrical designers, of the developers, to set their own buildings up for the most success. But hopefully these will be some good things to help folks exploring these types of issues. So as I mentioned, I'll say some things that apply generally to multifamily apartments, and then I'll speak secondly about townhouses and single family homes. So in the multifamily space, as I noted, you could do unmanaged dedicated circuits to each parking space, but that's going to be relatively expensive. So I think the vast majority of developments will use load sharing to achieve this. For the reasons we noted, it'll reduce the size of electrical systems. One thing that's important to note is that when you're designing for this type of load management, it does mean that you need to have charging stations that are going to be compatible with one another, and they need to be networked, able to communicate. So you can get a dumb charger for like $300, maybe $500 installed. These network charging stations to date can be more expensive, maybe $1,000 to $2,000. So it becomes just a little bit more important that we're actually setting the buildings up for success, and we're not just putting in the infrastructure, but going to associate them with the service that's going to give them a good quality of experience, so they don't need to replace that charging station preemptively. So I'll say a bit more about that momentarily. Of the sort of ways you could design branch circuits, I'd say 4-share on 40 amp is like bread and butter. It's compatible with basically all charging service providers and all EVC that are designed for this type of multifamily market, and it meets Toronto's performance requirements. We've got that same sort of ability to do 4-share and 40 amp in most places in BC. I'd say that's what 95% of the developments are using. That being said, there are some other design strategies that it's useful to keep in the back of our mind. Hey, this could add more value and might become more viable in the future. So something like 10-share on 80 amp currently is much less common. There's currently barriers to implementing that in the Canadian Electrical Code that maybe I won't go into now, but I could nerd out with anyone if they want to hear more afterwards. But we're working on addressing those types of barriers. Because of those barriers, there's fewer compatible charging station products, so it's sort of less suited to a variety of EV charging service providers. But maybe in a few years from now, once those barriers are taken care of, more products come to market, this could actually be a lower cost sort of way of designing this infrastructure. So the way we do it for the first couple of applications might not be the way it looks like in the future. Also, as I noted, service monitoring is pretty rare, but it can be a valuable design strategy to avoid an electrical service upgrade if that's a real challenge. So when you're doing 4-share and 40 amp circuits, you might be increasing buildings' electrical loads 15%, probably less if there's other electrical systems in the buildings that are in there anyways. It would be a smaller sort of incremental increase. So the likelihood that's going to trigger a service upgrade that's going to be a real problem for the building and result in much greater expense for the developer tends to be pretty low, and there are design strategies besides service monitoring that can help you address that. But it can be a way to say, hey, in new construction, we're designing the building with the capability of implementing that service monitoring. So we aren't going to do that service upgrade. We're just going to monitor the building's consumption for the first year and install that service monitoring if it's necessary. Now, the Canadian Electrical Code is inherently really conservative. Multifamily pretty much always is only using maybe 30, maybe 50% of the actual electrical capacity in that building at its absolute maximum. So there tends to be a lot of spare capacity. The vast majority of the time, you design for the ability to use service monitoring, but you wouldn't actually ever need it because lo and behold, there's tons of spare capacity in the building and it can handle those additional EV loads. So if you're running into a real problem, like, boy, we've got an expensive electrical service upgrade that we wouldn't have had otherwise if it weren't for these EV requirements, or maybe we wouldn't have had if we weren't electrifying other building systems like a heat pump, hot water heater. Think about using EV service monitoring, help the Electrical Safety Authority get comfortable with it, because it can provide a lot of value in these sort of circumstances. So in buildings like townhomes or single family homes where you've got a private parking space that's associated, like just attached to that unit, it's your garage in your townhome or single family home, most of the time developments will implement a 40 amp service from their panel to the parking space, and it'll be very cost effective, not a big deal. There's capacity on the panel and you can just go ahead and do that. Very simple, no problem. Some of the time, especially probably in larger subdivisions or townhouse developments, you would need to either upgrade your panel size, and that might increase costs, or upgrade your service size, and that might increase costs. So there's different, I'd say, steps to follow. I mean, firstly, just consider, is increasing those costs really that big of a deal, or is it going to be kind of a wash and we can just go to a larger service size? That might be the simplest thing to do. If it's just a one-car garage, you can get away with a 20 amp circuit to that garage. That's allowable within Toronto's performance requirements. A lot of people don't think of that for EV charging, but 20 amps is less than 40 amps. So that can be a way to have your easy charging loads. Maybe that'll solve the problem. If it doesn't, then you next might want to consider, can we do sort of a switching control scheme where either your dryer can be on or your EV, but not both? That can solve the problem, especially in single family homes, can help, although for, again, issues, we can talk about, but I won't get into here. This doesn't necessarily solve all the issues with, let's say, a townhome or feeder monitoring types of systems. And finally, if those don't work, then that same sort of designing for the use of service monitoring can be used. So I'd say that's sort of the order of operations of strategies you want to consider in those types of developments. And these are just examples of two products. AC Dandy is a Canadian company, and they have what they call a load saver. And so it lets either your stove or your dryer be on, or your, well, in this case, a hot tub, but can be an EV charger be on, but not both. And RV's a Quebec company. They've got an interesting piece of technology that basically monitors the feed coming from your meter to your panel. And if there's capacity there, then it's allowing your EV charger to charge. And these are both, I'd say, the largest providers of this sort of thing, although blanking on the name of it, there certainly are a variety of other products that have been deployed in the market as well. And I think it's a pretty dynamic space. And lastly, just a comment, and this is touching on something I mentioned previously, but the importance of setting the building up for success by providing them with an EV charging service provider that'll work with the building. As I mentioned, you want to make sure the building has charging stations, EV supply equipment that are compatible with the energy management system for the building. So it's best practice for the developer to be associating their building with a charging service provider from the outset. It's typically good if you've got an electrical engineer on board who's going to have more expertise in this sort of thing than handing it over to a condo board to try to figure out. So key considerations when you're making these sort of decisions, of course, price, both of how much it's going to cost the occupants for your EV chargers, as well as ongoing networking fees, the quality of chargers. Some are pretty robust, so it depends on your sort of circumstance. There can sometimes be vandalism. A flow charger, a lot of the times you could hit that thing with a baseball bat, it'll be okay. There's other ones that will certainly not be good for it. Warranties, what you perceive as the staying power of the company, are they likely to be around in a couple of years? And also proprietary systems versus open protocols. So there is this open charge point protocol. Unfortunately, it's not an official international standard yet. It's still just sort of a de facto standard protocol that a lot of different charging service providers, although not all, choose to use. And it facilitates communications that allows for that EV energy management, and then other sorts of functions like your charging drivers for the power they're using, app communications, and that sort of thing. So if you're using open communications protocols, that lets you, if as a building, say, hey, we've got these charging stations that are OCPP compliant fully. They can use any charging service provider that communicates with OCPP and has other sorts of common systems, communication systems. So it will allow for more flexibility for the building in the future and not lock you into a provider. Right now, it is challenging because some of the more well-established entities do have proprietary systems, so it's not necessarily cut and dry that you absolutely should go with OCPP compliance, but I think it's a good thing for the industry generally to be trying to encourage greater use of open systems. And finally, the local contractor networks and ability to provide quick service if there is anything going on. So that's all I wanted to mention around new construction. I'm probably at time. I'm not sure if we should go into considerations for existing buildings. It might be about 5 minutes of content.
I think we should be, yeah.
We're okay?
I think we're good, yeah.
Okay, yeah. So I'll touch on what to do in existing buildings. So broadly, sorry, this is a bit of an eye chart, but there's broadly two ways that you can provide EV charging in existing multifamily buildings. By far the most common would be incrementally adding a couple of charging stations, a few EVSE at a time. So oftentimes this will be in a commonly accessible parking area like visitor parking, although sometimes people will get a circuit right to their parking space. You're adding a few at a time. And then as more drivers are adopting EVs, presumably you're thinking, well, we're gonna expand on that initial deployment and need to add more and more charging stations throughout the building. And that'll just be accelerating how much needs to be deployed and the extent to which you're doing these sorts of incremental additions. So this will typically, be, as I mentioned at the outset, maybe on average $8,000 a parking space to do this. It might be if you're adding, let's say, 3 charging stations, it's like $25,000. So a relatively lower initial price tag, but really it's going to wind up being a fair bit more expensive over the lifetime of the building than the next option. I'll note. You also run into this issue where you're adding a couple of charging stations at a time and not planning how you're going to use the limited electrical capacity that's in these existing buildings most effectively. You can run into capacity constraints. You can certainly start using up all the available spare breaker space in the buildings. You can implement, let's say, new feeders or new breakers on switchgear that aren't going to be sized appropriately to handle the next tranche of EV chargers that want to come in. So you're risking a fair bit of stranded assets when you're doing this type of approach. And I think we're going to have a lot of buildings, 3 years, 5 years down the line to go, shoot, we didn't do this quite the right way. We've got to rip out this electrical infrastructure that we paid, $8,000 a parking space for initially. So it can be, a decent foot in the door. I'm not saying we shouldn't encourage a couple of charging stations at a time being deployed in multifamily buildings. Maybe it's the best we can do, and it's important to provide some charging infrastructure, but I'd say it's definitely not optimal. Much less common, but a lot greater value is doing what I call a comprehensive EV ready retrofit. So we've kind of pioneered this approach in a number of buildings in just the last few years. What it is one major electrical renovation where you're going in and you're doing the same future proofing that we typically put into new construction in one fell swoop in existing buildings. And typically there's enough electrical capacity in these buildings when you design for EV energy management to be able to provide an outlet beside each parking space. You need to do, add new distribution switchgear, new feeders, but you design everything up front so that you're going to be able to easily then install a charging station at everyone's assigned parking space over time and get people a great quality of charge in their home parking space. So it's certainly more money up front, one-time expense, but it's a lot lower cost overall. So in my previous work, AS Engineering, I'd say kind of piloted this approach. Well, it's beyond pilot stage, but we were the first to sort of do this type of approach. Our average was about $1,000 to $1,200 per parking space to make each parking space EV ready. And then over time, as drivers adopted charging stations, that's like $1,000 to $2,000 expense, depending on which EV charging service provider that they went with. So you can see it's a lot greater value to do things this way, although it does entail that one-time higher upfront expense. I'd also say this provides a lot more convenience for your drivers. If you're doing this kind of on an incremental approach, every time you need to get a condo board's permission to change common property to add a wire in your building, that is months, if not years, of wrangling with volunteer boards that don't, necessarily have very much, typically don't have any technical background in these types of issues. And there's a lot of delay and uncertainty associated with that. And then you also, if you're putting it into visitor parking spaces or maybe sharing that infrastructure, the only way to effectively make the best use of that limited electrical capacity in the building would be expect everyone to, okay, I'm done charging at 2 a.m. I'm going to move off and you move your vehicle on. That just doesn't happen. So you wind up wasting a lot of that limited electrical capacity that's in these buildings. So with this comprehensive EV ready approach, instead, everyone's got that charging capacity at their parking space. They have an easy process to install a charging station. And because the energy management's doing the sharing, not the drivers moving their vehicles, it's a lot more efficient use of that limited electrical capacity that's in the buildings. So makes a lot more sense, but it's extremely rare. There's a lot of barriers and challenges to this happening. Notably, pretty much every program in North America, except for BC, which I'll chat about shortly, just focuses on providing a couple of charging stations at a time in multifamily. So there's no sort of programmatic encouragement of buildings to do it in this more comprehensive way yet, although I think there's a good chance it's going to be changing relatively soon. It does entail significant upfront costs. So let's say you've got a 100-unit building. Let's say you average $1,000 a parking space. That's still 100 grand, which not many condo boards have kicking around in their contingency reserves and not thinking, well, we also need to redo the roof for the landscaping or something like that. So there is this significant one-time expense that's associated with it. And there's real informational barriers. Oftentimes, buildings are not working with electrical engineers who would be advising them to do this. I think this sort of model and type of service is relatively new. It hasn't occurred to many entities to try to offer it. So there's a lot of kind of development of the sector that needs to occur. And there's kind of, I'd say, long decision-making processes to choose to do this. And so the consultants that would be providing this type of service would be assuming a fair bit of risk and might not want to go ahead and offer this. You might just be like, okay, as a contractor, I'm just going to try to sell this building on adding 1 or 2 charging stations, make my $16,000 and move on to the next building, because that's just conceptually easier for people to wrap their heads around. And you can also get bad advice if you are trying to do these comprehensive retrofits. This is a complicated electrical engineering project that you really need to think carefully about how you're going to do, but it is, in our experience, possible to do it right in pretty much every building. I think we've probably assessed 70 buildings in my previous role for this type of service. We never found one where you couldn't actually make every parking space EV ready, give people a good quality charge, provided you were designing for EV energy management appropriately. So I guess about 2.5 years ago, I was lucky enough to work with BC Hydro, and we designed the Clean BC EV Ready rebate program. So what it does is it provides 75% of the costs, up to only $3,000. It might be smart to increase that a little bit, of the cost of what we were calling an EV Ready plan. So basically that's an electrical feasibility study to say, here's how you would do it in this building. It's not detailed design drawings, but it's a sort of electrical schematic design and costing that's sufficient for budgeting purposes for the building to say, yep, we know it'll cost about 100 grand to do it in this 100-unit building. We're going to budget for 120, and we'll then be able to move ahead and make this decision. So there's support for this kind of feasibility study. And then there's 50% of the cost, up to $600 per parking space, to actually complete that retrofit according to that EV Ready plan. So significant support for the buildings to undertake this type of work, up to 80 grand a building. I think there actually shouldn't be a maximum cap for it, because you do have some developments that are 500 units, and then that's a lot less valuable, but that's a lot of voters and it's a lot of potential drivers in those buildings. So it makes sense to give them the same benefit that you're providing for folks that live in smaller format types of multifamily buildings. And then there's also rebates that are associated with the chargers. So in BC, we offer both this kind of comprehensive program as well as a parallel program that's similar to one that's offered by the federal government right now, that'll add a couple of charging stations at a time in multifamily buildings. There's been tremendous uptake of this in the 1.5 years that this program's been in the market. I think program wide, and condos take a long time to make decisions, but there's been about 300 that have made this sort of, this is as of a couple of months ago, presumably it's more now, done this plan. And I think it's 50 that are pursuing the upgrades to date, a lot more in that consideration phase, considering the feedback in the plan and waiting for their AGM to make the decision. Just a quick case study. This is one of the first buildings that did this, that's in West Vancouver. It was 46 parking spaces. We did this kind of simple 4-strand 40 amp circuits. There was no electrical service upgrade involved. And the costs all in were about $1,300 a parking space, including the infrastructure as well as the detailed electrical design. There are a number where it's wound up being lower cost than that to do it. But it does certainly range. Every building's different, construction costs are different. But I think it's a really promising model that hopefully can get greater traction all across North America. So thanks so much, and we're looking forward to question time.
No, it's smart. I just have to load a presentation, so if there are any questions.
Oh, there is a question.
There is a question.
Take it.
Yeah, I was just wondering, so the open protocol for the charge stations, does that have to be compatible with the energy management, like the energy management system for that?
Yeah.
Or is it sort of an open?
That's a good question. So Open Charge Point Protocol has a variety of different categories of information that it can communicate. So it's got sort of standardized ways of communicating to drivers how much it costs to use this, of communicating, you know, your session is authenticated, you can charge. And then there's also one category within that that is able to communicate, do EV energy management between your different charging stations. So a challenge is that some chargers could use Open Charge Point Protocol to communicate certain information, but not others. And it's not like an international standard that you can certify to. There is a way to sort of test compliance. But some charging stations will communicate with OCPP for some things, but not for others. I'd say it's a situation that's challenging right now. It's pretty dynamic. Things are changing, you know, monthly. I suspect that in the medium term, couple of years, things are going to move around communicating through open protocols. There's different versions of this protocol as well. So some of the more advanced charging service providers that have more established in the market are still using proprietary communications for certain things, because past versions of OCPP don't have the functionality that they want it to yet. But for future versions, like the newest versions do, but they just need to get everything up and speaking that. So sorry, that's kind of a complicated answer, but yeah, it is important when you're doing designs, which is a lot of them, where you've got that kind of EV energy management facilitated load sharing going on, that load sharing, amongst other things, would be done through OCPP. And to further complicate things, the last thing I'll mention is OCPP. There's an OSI model for open systems integration. So it's a way of thinking about the so-called 7 layers of open communications. So at the most basic level, there's like infrastructure. You can't have one thing communicating with wireless and one thing with cellular Ethernet and then communicating with each other, but there's also different sorts of layers. So OCPP is only one layer of that communications protocol. So for a system to be truly open, it also needs to be able to communicate or to be working to be open along other types of layers of that broader OSI model. So anyways, hopefully that's not too Greek, but there's those types of considerations that your electrical designers and folks choosing this type of infrastructure can help think about.
So my follow-up question to that is, maybe linked to the residential buildings, charge station range. Is the intention of the next step to do like a mass retrofit of that space to install all EV charge stations in that MERV? Or would it be to set up the owners of those MERVs for piecemeal installation?
Yeah, I think it makes more sense to associate those multifamily buildings with a charging service provider. That could change in the future. And ideally what will happen is you'll say to these charging service providers, hey, we want proof that your systems are compatible with other charging service providers that might take over these sorts of buildings. So if you're working with Switch, you'd say, we really are keen to work with you. We think you offer a great service, but we also want to show that, hey, we're able to switch to, let's say, Amp Up or some other charging service provider in the future. Show us demonstrations where there's been a variety of different charging station vendors, makes and models that have been deployed using your service, and it being operated first by you guys and others. There's a lot of effort right now in the space and successful demonstrations showing interoperability between these different types of services. It just hasn't been completely standardized at this point. So I think in the absence of that, it behooves the industry to sort of request from these folks documentation of that type of ability. Yeah.
We probably have time for another question if anybody else has a question for Brendan or Lisa or Sophie.
And Brendan, so in your studies, have you looked into the impact?
In your studies, have you looked into the cost on owners and the transformers, how it connects up to the grid?
We have these large transformers for a condo, for instance, that are energized all the time for EV ready stations, right? That may or may not ever come. It could be a significant cost on landlord's electricity costs, right?
Well, there's no
Energized is what I'm saying. Transformers, some of them could be pretty large.
Yeah, we haven't looked at that cost, but oftentimes, like, these circuits, the breaker's not flipped, but the breaker is there and able to provide that power.
Right, but the 122 volt transformer would be energized. Say you had 100 stations or EV ready stations, but the
the transformer would be energized.
Yeah, and the transformer's energized.
Yeah.
So you have a big 500 kVA transformer, for instance, on a building.
Yeah, and what does that cost to have that?
Sections.
Yeah, that damn higher load essentially.
In that transformer being energized, right?
Yeah.
And I don't think that's being recouped by the sale and reimbursement to the landlord.
Yeah, no, it's a fair point. I think it's I don't see how you avoid that issue. is one thing without doing this, and I think it's better to do that, but there is that essentially like vampire load that's gonna come with that transformer having power through it.
It's smaller individual transformers.
Yeah.
Rather than
That could be a thought. Yeah, we haven't looked into that, but that's an interesting question. Yeah,
Because if you take that now across the entire city that wants to go EV ready everywhere, then it's a significant impact to the grid itself, right?
Mhm.
To have all these energized transformers.
We have not looked into that. I'm not necessarily willing to see that it would be like a significant impact without having seen a study of what that would be. I mean, transformers in general are way under capacity. Like the loading, I think on average is
Correct.
15% or whatever. So how much like incremental impact that would be is something of an open question, especially when the total loads for this and the amount of transformer capacity you'd be adding if you're designing for load management, relatively modest. Like in the studies we've done, let's say with the most
These questions are all related to the transformer, what it means for retrofits, and for how these buildings would interact with the grid itself.
of those buildings, right? Once all the vehicles are charging. So it's a relatively small amount of transformer capacity relative to what exists in those buildings already. Yeah.
There is a question from if we could say, thanks for touching on the electrical capacity issue. Can you elaborate on the total cost to add 20% of EV chargers to a new development? Cost for the incremental electricity transformer, upsize, infrastructure, smart chargers. Smart chargers, sorry. Yeah, the smart chargers. I mean,
How much
I'll
the
link
EVC
them.
would cost?
Well, if you
Yeah.
add 20% EV chargers to new development, but it would all depend on how much sharing you're doing or whether you're using service management to the cost. So
Yeah, I mean, I think if the question is, what would it cost to add EV chargers to 20% of parking spaces that are made EV ready would feature EV chargers. If we assumed each EV charger was $2,000 and the cost of making that parking space EV ready was $1,000, which, you know, these are just very high level numbers. Every building is different. It can vary 100% either way potentially. Although maybe not on the upside. But then that might be like 40% of the cost, but really that's something you need to answer for each development.
and that's also something in the EVCosting study, which I'll actually put into the links and then send out to everybody as well, so that they have access to the EVCosting study that did look at 20%, because that was one of the TGS requirements. So that was one scenario that we played out in the costing study.
Yeah,